All right, good morning. My name is Luka Velemir. I am an obstetrician from France, as you can understand. And today I'd like to show you 3 digital tools we have built to answer a simple question. When it comes to labor, how is this fetus? So the problem on the left, we've been doing for decades. FIGO, NIS, is this trace normal or abnormal? Poor inter-observer agreement, pattern recognition, no physiological reasoning. On the right, the physiological approach, like Susanna demonstrated this morning. Read the CTG as a story about this specific fetus, what he is telling about him, organ by organ. The problem was there was no structured tool existing to implement this at the bedside. So we built 3, a rule-based assessment tool for admission triage, transparent, educational, then a Travis mini application, an AI app, open access on the stores, which classifies CTG pictures in real time, and then an hypoxia engine, specialized deep learning model built for software and monitor integration. So is this fetus fit for labor? It asks 5 questions, each targeting a specific organ system, baseline for the heart, variability and cycling for autonomic nervous system, acceleration for somatic nervous system, decelerations for placental reserve. These combinations are mapped to 11 clinical scenarios from fit for labor down to preterminal chronic hypoxia. Each scenario has a specific pathophysiology background and a specific management. So when the pattern doesn't match any scenario, at 5 out of 5 questions, then the tool says, ask a senior. It never guesses. So case 1, all questions are green, it's fit for labor. This is a similar case that Susanna presented. So the questions goes to chronic hypoxia diagnosis. As I can say, the chronic hypoxia, most often they don't have a low pH, but they have a bad outcome. So you can see that when you get this diagnosis, notify pediatrician because they should be there to rescue the baby. And then this interesting case that Sophia shared with me yesterday. So we tried the app immediately. So it's a CTG that it was a bit problematic. The resident, even the seniors, they didn't know what to do. So if you look at the triage simple rule-based algorithm, it did catch the fetal-maternal hemorrhage. And indeed, there was a very low hemoglobin. Okay, so now what do we do during labor? The trace evolves continuously, so the clinician needs real-time pattern recognition support. That's where we use AI. So Travis Mini app, you know that now there's a gap. All published deep learning models for CTG analysis require access to a raw digital signal. But in most delivery rooms worldwide, the clinician sees a paper trace or a monitor screen, not a data file. So that's why we developed this picture app analysis, and AI classifies the pattern. So we do classify in 10 classification categories that are based on physiological pathology analysis. So you can find all types of hypoxia, also zigzag pattern, typical and atypical sinusoidal pattern, unstable baseline. The performance of this model is not bad, actually. It was trained on 5+K CTG pictures, labeled by 2 CTG experts. So we rarely miss pathology, and when we mismatch, it's not a big deal because both, like gradually evolving hypoxia and subacute hypoxia, they require intervention, just different urgencies. And then finally, we developed this hypoxia classification engine, focusing only on 5 classes of hypoxia. So there is a strong correlation between hypoxia features on CTG and MRI and outcomes. And so it's really interesting to guide the clinician in when he should intervene. So architecture, I'm sorry, I don't have a big engineering and computer science background, so I will go fast on this. Here are the results. So accuracy 0.87, and we do not do very well on decompensated gradually evolving hypoxia because we lack a bit of data for this. Otherwise, we do very well on other classes. So we tried many different models. And EfficientNet V25CRNN was doing the best. So take home message, try it because you are open access. And that's it. Thank you.
Really nice to see this fact that you can use what a lot of information we have, but it's just not electronic yet. I was wondering how susceptible are your models to, say, the image quality, and if you account for that. And also, is it also possible that it's capable of differentiating between different paper speeds? Is that also included?
So it can only analyze cropped pictures on CTG. If you take a picture of screen and there is a mother's heart or the contraction line, it will be messy. So there's the user has to crop exactly the CTG only. And then there is a pre-processing program that is cleaning everything.
Okay, cool. Thanks.
Any other questions?
Thank you.